Okay, let's start. Okay, let's see the difference between the 4G and the 5G, and how the 5G is improved from our 4G. First, for the latency, and for LT just can provide around 30 to 15 millisecond end-to-end latency. But our 4G can realize the 1 millisecond latency. So, our 4G or 5G has a good performance about the latency. So 5G can support the like V2X, like the like the remote control. About the throughput, our LT network just can support the 100 Mbps to one or TDD system, TDD system, and our 5G system can support 5G systems can support 150 Mbps. And for our 4G or 5G can support 10 Gbps, 10 Gbps. For connection, the connection, and for LTE just 10 kilo, but for our 5G can support 1000 K, and the connection is also very larger than our 4G, and network architecture. Our 4G or 5G can support slicing capability. And what's the slicing? And the next we are introduced in detail. And the slicing is one key technology, one key features of 5G. Our 5G network can provide the different service for the different user. For example, if one user wants low latency, we can use the slicing. We can cut the network in several slicing. For example, slicing 1, slicing 1.
Sofia,
for example, slicing 1. Slicing 1, this slicing just support the low latency. Slicing 1. And for example, slicing 2. Slicing 2, I want to support the high throughput. We need a big bandwidth. For example, slicing 3. We need the low latency. We need the high throughput or big bandwidth. So the network, the physical network can be cut into several logical slicing, logical networking. The slicing can fully utilize the network resource. Our 4G, or 4G just support the QoS. QoS. Our 4G network is the child-based network, but our 5G, it can make sure the network, like the latency, like the bandwidth, and so on, is the insured network. because the 5G can support the slicing. And this part, architecture, next I will introduce in detail.
Excuse me?
Please.
About the comparison, the number of connections per square kilometers. For LTE, I think it's only 1K, not 10K.
Only 1K?
Yes.
You said 1K. LTE network?
Yes, so the capacity is 1,000 times, not 100 times.
Oh, okay. Next, after class, I check it. Okay.
Okay. Thank you.
You say it's a 1K. Really? You mean it's 1K?
Excuse me, I have a question.
Please.
For slicing capability, do you mean that each slice mean a certain requirement for 5G?
Yeah.
Okay,
yeah.
But for LTE, the network architecture is constant, is fixed?
It has the QoS, but this QoS is the child best, not the make sure network. But the 5G, it make
More flexible.
Yeah, more flexible. Yes, more flexible and more insured. More insured. Yeah.
Okay, thanks.
And the NFV, it means the network function virtualization. You know, our 5G core network will depend on the cloud, and the cloud infrastructure can support the slicing. Slicing is more because the cloud infrastructure, so it can be more flexible than the 4G. And NFV means the network function virtualization, and all the network functions will based on the cloud. This is for core network. Core network. For core network. And SDN means the software-defined network. This is used for in our IP transmission. IP transmission. And also for because the slicing, our transmission network also need more flexible. So SDN can meet this technology can meet the requirement depend on different service to allocate the different transmission resource to the different service. Yeah, this is all about 5G. 5G network will be more flexible than the 4G. Yeah. And this picture show us some typical service and the requirement of a network. For example, for some automatic driving, and it's a very sensitive latency. So the latency must be small and small. Can reach the 1 millisecond. 1 millisecond. And it doesn't need high throughput, maybe 10 giga. It just need 10 Mbps. Is enough. And this is the speed of bandwidth of the network. And for the virtual reality, for these scenarios, it needs a large bandwidth, maybe 1 Gbps, to support HD video, support the 3D video, and it also has a high requirement latency. Latency. It can reach the 10 ms, 10 ms. If the latency is too large, it may make people uncomfortable. And for the sensor, it doesn't not need too much requirement of latency, and it also don't need too much bandwidth. It needs a huge number of connection. It just need a large connection. So different requirements need different 5G network capabilities. So this is one reason why we need the slicing, why we need the NFV or SDN. So this is one feature. Let's compared with the 4G. It can serve our network resource and make different slicing for the different user. The network resource will be fully utilized. And 5G equal to platform. We can say the 5G can provide us a platforms. Can provide the mobile network to 5G and the mobile IoT, or 5G. Both can support internet access and IoT access. And on these platforms, it can provide plenty of service to our user. This user can be a customer, like our customer. They can be the vertical industry. 5G can enable a vertical industry, and also 5G can also for the carrier, it's very easy to deploy the service, very easy to service. So 5G is the platform for new applications, new business modes, and a new industry. So why we see that 4G change our life and 5G change our society. And actually 5G will be play a important role in the vertical industry. Actually, in China, the carrier, the operator, started to explore the 5G used in vertical industry, like the port, like some pairing factory, like in the police, in the public safety. In China, in the port, we can the port deploy the 5G network in the port, and the worker can use the 5G network to control the AGV, control the car. So the 5G, we say that 5G enable the vertical industry, especially in the harsh environment, like the coal, like the mine factory. The sun working environment is very dangerous. So we can use our 5G network to control the machine or control the tank remotely to realize the automatic driving in the coal or mine. Yeah. This is why we say 5G is the platform. The next is the development of 5G protocol standardization. The 5G protocol standardization is very, very important for our CT communication technology. Our 4G, our 3G, 4G, and 5G, even 6G. All wireless communication must have the protocol standardization, and then the vendor and the vendor will, like the Huawei, will produce the production depend on the protocol. And we can see 3GPP. 3GPP I have introduced is one organization that realize the 5G's which inversion by the ITU. Our 3G, our 4G, and our 5G, even 6G, defined by the 3GPP. And you can also see the 3GPP2. Another 3GPP2 list organization. We may saw the CDMA 2000, CDMA 2000, and the UMD. This 3G standard defined by the 3GPP2. This organization is the North American, but now it's over. It's finished. All the communication technology will have all by the 3G PP. This organization. And we can see here, and this is our 4Gs. 4Gs realized from our 3G from the realized 99. Realized that WCDMA, and to release 5 to 6 to release 10, release 11, and then to release 12, and each release will have each release enhance the ping rate. And for our 5G, 5G from the release 50, there are two paths. One is this one. We call it ELT. Another is new 5G new radio. 5G new radio. And there are two paths. And this path maybe just the LTE space station upgrade the software to the ELTE to ELT. We also call it the 5G. 5G because some in our 4G, some operator have invested a lot of money in our 4G. 4G. So there are many 4G base station. They don't want cost too much money to deploy 5G. So it just upgrade the software in the older 4G base station and use we call it ELT can also meet the requirement, meet the 5G requirement, and use the EPC 4G network, 4G core network, like this one, Another path we call it the 5G new radio, from release 15. The new radio, we use the new radio, the 5G base station, 5G base station NR, 5G base station NR to and the 5G core, 5G core next generation core network. Use this one. Actually, in China, use this one. NR and 5G core, 5G core. And this is the 5G standardization. And operators of Japan, carrier, and Verizon formed alliance, OTSA. These two operator, these are four operator, KT from Korea, and Verizon from America, and SK from Korea, and Docomo from Japan. And these four operator for a new organization, OTSA, 5G Open Child Specification Alliance. This new organization, their purpose is to push the 5G standardization faster. They are not satisfied with the 3GPP progress. They feel it's very too slow, and it can't. It's against their all benefits. They want to accurate the 5G standardization. And they want to push the faster and want to define the new 5G standardization. Actually, they focus on FWA. They use this frequency. FWA means the fixed wireless access. Actually, it uses the CPE get the wireless signal into the Wi-Fi, and then provide the network service to the customer. And this technique development is mainly from the LT, and some enhancement of LT. And they want to provide the broadband access using wireless to the user. So they form the new organization, OTSA. And the non-standard.
Sorry, just
please.
Excuse me. Just I have one question. Is there any network deployed based on this organization? Is there any real network?
Maybe in this country, maybe in this just in the earlier stage, maybe 2017, this country like a carrier, Japan, or American use this standardization. But now all the world just use the 3GPP, use this organization. All the world use this standardization, and this standardization is finished. Include this operator also or by the 3GPP standardization. Yeah.
Okay, so it means it is not deployed yet.
Yeah,
Even in Japan and Korea, it is not deployed yet.
Maybe at the early stage, they may use this standard, but now all the operator will all buy a 3GPP. Yeah.
Okay. Thank you.
Yeah.
Thank you.
And you know, the non-standard OTSA may impose the risk of damage the 5G universal standard and separating industry tree. You know, if the standard is not unified, may improve the investment cost, and or user or customer will pay more money. Like our 3G, they are three typical technology: W CDMA, WCDMA, and TD-SCDMA, TD-SCDMA, SCDMA, and CDMA 2000, CDMA 2000 in 3G, and 4G, 4G, TD-LT, TD-LT, and FDD-LT, FDD-LT. In our 5G, just NR, new radio. So the standardization is unified. It's good for the operator and the inventor. It can decrease the investment or the cost. Yeah. So 3GPP accurate 5G, push the 5G protocol standardization. 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 And now all the operator and the vendor all buy the 3GPP standardization. And we can see here from the release 15 to release 16, and the release 16, release 15, we can see here phase 1. Phase 1. This is phase 1.1. Phase 1.1, and this is phase 1.2. Phase 1.1 is a non-standalone, and phase 0.2 is a standalone. Non-standalone means the 5G base station will be deployed together with the 4G base station, and the non-standalone means just have the 5G base station. And this release 15 have frozen in the middle of 2015 and 18. Another release 16 actually because of the COVID-19 pandemic, it's later in 2020, maybe last month, July 3rd, the release 16 frozen. Actually, in fact, maybe in 2019, but because of the pandemic, so it's later. In July 3rd, July 3rd, the R16 frozen. This frozen focus on NR, and release 16 support the EMBB, URLLC, and some MMTC, and phase 1.1 just focus on EMBB, and phase 1.2 support EMBB and some URLLC. This is the reason. This is the standardization. Standardization. Okay, have any question? Hello? Okay, let's continue. And this frozen of the R15 phase 1 non-standalone. You know, non-standalone just can suppose the EMBB scenarios. EMBB. Actually, in China, last year and the beginning of this year, the operator just deploy the NSA networking. But now the operator started to deploy SA, and SA can support the EMBB, can support the URLLC, and can support the MMTC, some MMTC, and the release 60 can support these three typical scenarios. This is our standardization, and actually this R60 frozen in last month. Yeah, this is our standardization. And technology about the 5G, the construction of NR technical free network. First, the new wave 4, like filter OFDM. And next we'll introduce in detail. You know, our 4G just use the OFDM, and OFDM has a high efficiency than the OFDM. And you, please, have any question?
Yeah, you know, I just have some concern regarding the release 16.
This one.
Based on the latest, like research, in release 16, release 16 mainly focused on URLLC, because EMBB was already achieved in release 15. So massive type communication still, in the future release based on the 3GPP, they will work on it and achieve in terms of the satisfying this key performance indicator. So release 16 is only the main focus of release 16 is to satisfy URLLC.
Yeah.
Is that?
Yeah. Focus on URLLC and some part of MMTC. And all MMTC, this standard frozen maybe in R17 maybe 2021.
21, yeah.
Yeah.
Okay, thank you.
Yeah, for this R6 may focus on the MMTC. Actually, the NB-IoT have become the 5G standardization of MMTC, NB-IoT.
So NB-IoT, is it embedded in the sub-6 gigahertz or millimeter wave?
Based on the first one.
Yeah, I mean the frequency band of NB-IoT.
Yeah.
Is it within the sub-6 gigahertz or millimeter wave?
No, sub-6G. Actually, the NB-IoT have deployed in our network.
So
we
you
use
mean
the low frequency band,
like LoRa or Sigfox? These can be considered as a NB-IoT, right? There are two technologies like Sigfox and LoRa. Yeah. These two technologies can be considered as a NB-IoT.
NB-IoT, just NB-IoT. You mean the LoRa and can be the NB Sigfox can be the NB-IoT?
Yes.
No, NB-IoT, just the NB-IoT. Different standard, different technology.
Yeah. Okay.
Yeah, and the NB-IoT, this network have been deployed in the operator, so it's very easy to become the 5G standard because in China, over million meter like our I would say the bicycle and the intelligent meeting. We use the NB-IoT, and now the operator also investment a lot of money in the NB-IoT. Yeah.
Okay. Thank you.
And then and I think today course the time is over. I think I hope left 3 minutes we can communicate. Have any question about today's course?
I have questions, if you mind.
Please.
Thank you very much, Mr. Chu. Just I have one question in terms of suggestions for keeping time of session. You hear me?
Please.
All we heard about 5G is advantages.
Yeah.
But in the same time, you see many rumors or some claiming about the 5G. When we use high frequency, a lot of electromagnetic waves will spread in space, in our environment, so it maybe has a negative impact in our health. And about in social media, there is many video talking about they connected between COVID-19 and 5G. They said this has a negative impact on human beings. That's maybe in the Wuhan, or maybe in China, the first stadium might be deployed 5G. So can you just arrange some time talking about the negative impact, about maybe modifying the change genetic or high impact on human being immune system and something like that. Just frankly speaking, just in our community, we have a lot of fear from when any company just coming and establishing new base station near in our houses. So we have a lot of fear from this huge electromagnetic wave in our space. Just if you have a time, just some short due to your investigations about this type of negative impact of electromagnetic wave radiation. Thank you very much.
Okay, thank you. Actually, you said the social media said the 5G 5G base station may spare the virus. I think is not based on the size. Based on the size is no according. Okay, the first and the next. In China, most of the big cities have deployed our 5G base station. 5G station in China start deploy the SA network, and now in our Huawei training center, we also be covered by the 5G signal. In China, the COVID-19 have controlled successfully. Some Western countries said the 5G may spare the COVID-19 virus. I can't understand why they have this opinion. The second, actually, the 5G base station, in Wuhan, may help the government to control the COVID-19, like the Huosengshan and the Leichensan Hospital. At that time, 5G base station is very easily deployed, can serve the times to provide network service for the doctor, like the remote health. If we use the fiber, it's very, very slow. So actually, the COVID-19 may promote the 5G development. Yeah. Some in Korea, this country also deploy their 5G network, and in Japan also deploy their 5G network. And in this country, I have no heard the song about the 5G base station may cause the COVID-19. I think it's no according. It's not based on the size. Yeah, it's my opinion.
Thank you very much. That's why 5G has changed our life. Maybe this one of the results changing our social distancing is also what happened now. Maybe this is one of in terms of change our society, isn't it?
Yeah. 5G will change our society. Not a bad effect. It's a good effect. At this time, it's the early stage of 5G. Some application is not appeared, like our 4G. In our 4G, in the early stage of 4G, some people also say the 4G, what's the function of 4G? And the 3G network also can provide a service for us. We can just see the picture, just see some video. But now the 4G is very, very used widely in our life, and people can't leave our 4G network. So maybe in the early stage of 5G network. So I think maybe 3 or 4 years, and the 4G network deploy well, and some application also will also be appeared So maybe several years later, we may see the 5G changed our society. Yeah.
Thank you very much.